Okay. Hi, my name is Jefferson Himmelman, and today we are going to learn about Taylor series. Taylor series. So basically, Taylor series is an approximation. We've used approximations before in calculus, for example, Riemann sums, to find areas under a curve of a function. But in this case, what a Taylor series is, it's an approximation for a function as a polynomial with an infinite number of terms. And so in having this small explanation, we're going to explain the definition of what a Taylor polynomial is. So a definition of nth term, nth degree Taylor polynomial. And this definition was invented by Brooke Taylor, hence why it's called Taylor series. And so what this definition says is that if f has n derivatives at x equal to c, then the polynomial of whatever term of x is equal to f of c plus f prime of c times x minus c, and then we'll see that there's also f double prime of c over 2 factorial x minus c squared. And so we could see this pattern eventually until we have f to the nth of c over n factorial times x minus c to the nth for f at c. And so you can see this polynomial as it continues on infinitely, depending on how many terms that we want. And notice how it says nth degree Taylor polynomial. So for example, this term here would be the zero degree polynomial. Up to here would be the first degree, up to here would be the second degree, up to here would be the third, and then it continues on to the third or the fourth. Now, there is another term for a polynomial, and that is called the definition of Maclaurin series. Definition of nth degree Maclaurin polynomial. And this was made by Colin Maclaurin. And what this basically is the Taylor series is basically the Taylor series, except it is always centered at x equals 0. So the rule is, or in this case c equals 0, the constant. So in this case, if c equals 0, then the polynomial of the nth term of x equals f of 0 plus f prime 0 plus, f prime 0 x plus f double prime 0 to factorial x squared. And so this continues on. We could say f third prime of 0 over 3 factorial and x cubed. And eventually this goes on into whatever the term is. And so basically it is following the Taylor series, the Taylor polynomial, except c equals 0, the constant is equal to 0. So whenever you have a Taylor series that has c equaling to 0, we can also call it a Maclaurin series. And notice it still follows the nth degree. So this would be the 0th degree, this would be the 1st degree, this would be the 2nd degree, and this would be the 3rd degree. So to sum that up, we're going to write the definition. Oops. We're going to write the definitions of Taylor and Maclaurin series. And basically that definition is based on the definitions of the polynomials that we just wrote, that if a function f has derivatives of all order at x equals c, then we could say, use the summation of n equals 0 infinitely to the f of n times c over n factorial times x minus c to the nth. And what that equals is the same thing that we've written for the definitions of the polynomials. And in here we are basically putting in the series, which is equal to whatever we put on top, and put whatever we wrote down in the beginning. So it would be minus c, and then plus, up to that same rule of f to the n times c over nth factorial times x minus c to the n plus. And so this is very important for understanding and finding polynomials, Taylor polynomials, and Taylor series, and being able to expand them. You can also see here that for the definition of an nth degree Taylor polynomial, we can also say, we also see this in tangent line approximation. And we can see here that it is basically f of x equals, or roughly equals, f of a plus f prime of a times x minus a. And so what that is a Taylor polynomial. This is a Taylor polynomial to the first degree. So we can see that this is the 0, and it's the first. So it's the Taylor polynomials to the first degree that approximates f of x for x near a. So you'll see that Taylor and Maclaurin series are going to be very useful and very going to appear a lot for the next few lessons, and that how we're going to set for some few examples and how they're important and what we could use them for.